air is wavelength for air is 6000 angstrom and in water the wavelength is 4500. Then the speed of light in the water will be, right? Okay, now first we know first what is the relation between velocity and wavelength. Velocity is directly proportional to wavelength. Yes. Okay, now here v1 by v2 equals to lambda 1 divided by lambda. Yes, this is the formula. Okay, but what they are asking, what is the speed of light in water medium they are asking, yes or no? That is v2 equals to v1 lambda 2 divided by lambda 1. Now v2 equals to, what is the value of v1 velocity, that is in air medium, 3 into 10 to the power of 8, yes, into lambda 2, that is 4500 angstrom divided by, again, that is wavelength in air 6000. Yes, here double zero get cancel, just simplify. This is 3 ones are 3 2s are, right? Okay, now 2 ones are, this is 2 2s are, again 2.5, that is 2.5 into 2.5 10 raised to minus 10. 2.5 into 10 raised to. I hope you written this one. Okay, I'll go to the next one. The refractive index of water with respect to air is, refractive index of water with respect to air is 2 by 3, and refractive index of glass with respect to air is, that is 3 by 2. Then refractive index of water with respect to glass. Refractive index of water with respect to air, they are asking, glass they are asking. This is students. Okay, now I will write the formula. That is refractive index of water with respect to glass. Yes or no? That we can write as refractive index of water divided by refractive index of glass. What is the value of refractive index of water with respect to air? That is 4 by 3 divided by, this is 3 by 2. Simplify. Again, refractive index of water with respect to glass equals to, this is 8 divided by 9. 8 divided by 9. Option B is the right answer. Note down, students. Okay. I'll go to the next one. The time requires to pass the light through a glass slab of 2 millimeter thickness is 2 millimeter thickness. Okay, students, what they are asking? They are asking what is the time required to pass the light in a glass slab. Yes or no? What is the formula? That formula is T equals to refractive index of glass into thickness divided by velocity of light. Right? Okay. Now, what is the refractive index of glass slab? Refractive index of glass slab is 1.5 into, how much is the thickness? 2 into 10 raised to minus 3 divided by, this is 3 into 10 raised to 8. Yes. 1.5 into 2, again 3. This whole term get cancelled. Okay, 10 raised to 8 goes up means 10 raised to minus 8. Minus 8, that is 3. That is 10 raised to minus 11. Option B is the right answer. Note down. Okay, I hope you clear. I'll move to the next one. This is refractive index of water is 4 by 3 and that of glass is 5 by 3. What will be critical angle? What will be critical angle for the ray of light entering water from the glass? Ray of light entering from water from the glass. Yes or no? Water to glass it is entering. Okay. What is the critical angle formula we are having, students? That is refractive index of glass with respect to water equals to 1 divided by sin C. What is that? 1 divided by sin C. Okay. Now, this is the students. Refractive index of glass divided by refractive index of water equals to 1 divided by sin C. Yes. Okay. What is the refractive index of glass here? 5 by 3. That is 5 by 3 divided by refractive index of water 4 by 3 equals to 1 divided by sin C. Yes. Here 3 and 3 get cancelled. What happens, students? Here 3 and 3 get cancelled. Now this will write sin C equals to 4, that goes 4 by 5. Now C equals to sin inverse of 4 by 5. Okay. What is the option, students? Here option A is the right answer. Okay, I hope you clear this one. We'll move to the next one. A fish looking up through water see the outside world contained in circular horizon. Right? If the refractive index of water is 4 by 3 and the fish is 12 centimeter below the surface. 12 centimeter below the surface, radius of this circle is okay, students. Here simplified formula is, students, r equals to 3h divided by root 7. 3h divided by root 7. Just here the fish, how much times it is below? 12 centimeter. So not times, 2 into 12 divided by root 7. Yes, simplify this one. That is again r equals to 36 divided by root 7. 36 divided by option B is the right answer. 36 divided by root 7. I hope you clear this one, students. Okay. These all problems to based on whatever we study is the formula of refraction as well as total internal reflection. Okay, now I'll move to the next one. Reflection on the convex surfaces. Here to consider convex surface. In the convex surface, by incidenting light from rarer medium to denser medium. Right, students, you will consider okay. Students, here we will consider a light from from where you are incidenting? A rarer medium to a denser where you are incidenting. Okay. What type of surface we consider? We consider convex surface. Convex surface. In convex surface, here the light incident from a point O, right? When it falls on a surface, the part of light get refracted. The part of light get refracted somewhere at point here. Okay, somewhere at this point it will fall. Okay, now what it makes? It makes a certain angle that we are measuring alpha, beta, gamma. By deriving that expression, what is the formula we are getting, students? That formula is refractive index of medium 1 is incident light. Where it is the incident light? This is N1 and this is N2. Yes or no? Okay, now where is our incident light? Incident light is in first medium. That is N1, mu1 divided by U. Direction negative. Right? Next, image formed in a second medium, mu2 divided by V. Mu2 divided by V. That difference, mu2 minus mu1 divided by R. Okay? This is the formula. Remember, students? The formula N1 divided by minus U plus N2 divided by V equals to N2 minus N1 divided by R. I told you, students, this is, we can use N or mu to indicate the refractive index. We can use mu or N. Okay, remember this formula for convex surface. Same as concave surface, but denser medium to a rarer medium. Denser medium to a rarer medium. That time the formula is N2 divided by U minus U plus N1 divided by V equals to N1 minus N2 divided by R. R is radius of curvature, N and mu is nothing but refractive index. This is the formula. Remember, students. Okay. This diagram, just you observe whatever we studied in our NCERT syllabus, right? But formula is very important. Okay. By solving the problems, very important. Okay. What type of surface is they given and what type of sign convention? How to use the sign convention? That is the matters first. Okay. Now I look at the next one. Lens maker formula. Here we studied both, that is concave as well as convex we studied. Convex surface as well as concave surface we use. Concave surface we use. By adding these two, this is convex and this is concave. By adding these two, what we can get here, students? We can get a lens. Okay, you can get a lens. The lens maker's formula. What is the lens maker's formula? That is 1 by minus U plus 1 by V equals to N minus 1 into 1 by R1 minus 1 by R. Yes? But what we are doing here, I will simplify this. If object is incident from infinity, from where it is incidenting, object is incident from infinity, where the image form exactly at the focus. Image form exactly at the focus. 1 by U, nothing but what? Infinity. If its goal is infinity, then this term becomes 0. Where we are getting the image? 1 by F we are getting. That is 1 by F equals to refractive index. Thus, N2 divided by N1 is nothing but what? N. Otherwise, I call it as a mu. Mu minus 1 into 1 by R1 minus 1 by R2. Okay, this is the formula. Okay, remember the formula, students? 1 by lens maker's formula. If two lenses, plano convex lenses, are bounded by each other, then what is the formula you are having? That is 1 by F equals to N minus 1 into 1 by R1 minus 1 by R2. Yes. Okay, I think you remembered the image formation in a lenses. But here two center of curvatures, okay, again, and two focal lengths, two optical centers as well as two focal lengths. This is from here to here, F1 and F2. Here already mentioned F1 and F2. Getting? Remember the formula? This one as well as this one. Very helpful by solving the problems. Okay, next one, thin lens formula. Thin lens is nothing but or contact of lens. Two lenses, first lens and second lens are placed each other. Okay, then first I'll tell you the lens formula. That is one lens, the image form object is placed on a above the principal axis where the image forms inverted image forms. Okay, in that side. Okay. What is the formula that time? That is 1 by v minus 1 by u equals to 1 by f. 1 by v minus 1 by u equals to 1 by f. Okay. Now object is placed above the principal axis and image, what type of image forms here? Virtual image. Sorry, real and inverted image. Real and inverted image forms. Okay, remember this formula also. But when two or three lenses placed in contact, that time what is the formula? That time the formula is 1 by f1 equals to 1 by f1 and 1 by f1 equals to 1 by f1 plus 1 by f. Okay. Okay. Before moving to that, I will define magnification. What is magnification? Magnification is defined as it is the ratio of height of the image to the height of the object. Okay. Now defined as height of the image to the height of the object. What is the formula here? That is v by u. What is the formula? V by u. Okay. Remember, but in mirror we are getting minus v by u, but in lens we are getting m equals to v by u. Okay. Then that term can be simplified. That term can be simplified in terms of v and f. V and f. That is the formula m equals to f minus v. F minus v divided by f. Right. Another one we can simplify in terms of incident light. M equals to f divided by f minus u. Remember these two formulas. This one, three formulas. Okay, I hope it clear. Next one, the thin lens in contact. Whatever now I am telling, previous I am telling, that is formula. The thin lens in contact. Okay, n number of lens we can place in contact. That is 1 by f equals to 1 by f1 plus 1 by f2 plus 1 by f3 dot up to 1 by f. Yes or no? Okay. Here another one term I will define, power of lens. Power of lens. What is power of lens? It is the reciprocal of focal length. It is the reciprocal of focal length is known as what we call it is a power of lens. The power of lens is measured in diopter. Power of lens is measured in a diopter. Okay. I hope you clear this one. I hope you clear up to this much. Yes. I discussed here up to the lens I discussed. Up to the lens I discussed. Based on this lens as well as surfaces, I will solve the problems. Okay, I hope you revise this all the formulas. Okay, so on the first problem, radius of curvature of convex lens is 40 centimeter. Convex lens is 40 centimeter for each surface. For each surface, its refractive index is 1.5. 1.5. The focal length will be 1.5. The focal length will be, yes. Okay. But students, here the sign convention matters. But students, here sign convention matters. See, here this is first one surface and this is another surface. Yes. Okay. Now here I will draw the principal axis. Yes. Optical center. This half is taken to be radius of curvature R2, and this half is taken to be radius of curvature R. The solutions. Okay. But what about this side? Negative. What about this side? Positive signs. Yes. Okay. Now here 1 by f equals to there's a formula we are having, that is n minus 1 into 1 by r1 minus 1 by r. The solutions. Okay. Now remember the sign convention. Here refractive index is 1.5 minus 1 into, okay, that side is positive, right? According to Cartesian sign convention, this side is positive. That is each side is same, 1 by 40, and this side negative minus into minus, that is plus 1 by 40. Yes? Okay, now this is 1 by f equals to 1 by f equals to 0.5 into, take LCM 40 and 2, that is 2 divided by 40. 20, right? So now, okay, now just f equals to here, this one I will take this side. Otherwise, directly you can divide also. 20 divided by 0.5. 20 divided by 0.5. Okay? Now, how much we can use one here? This one? 40 centimeters. 40 centimeters. Yes? I hope you clear. So you can write as 0.5, nothing but 1 by 2 for this one. 2, 20, 2 za 40. Okay, right? I hope you clear. I'll move to the next one. Convex lens of focal length 40 centimeter is in contact with concave lens of focal length. Concave lens of focal length 25 centimeter. The power of combination. So here matters. What type of lens they are taking? Convex lens. Convex lens. Another one is concave lens. Yes, convex as well as concave lens they are taking. If it is a convex lens, remember this one. If it is a convex lens, then focal length is measured in this direction. That is 40 plus 40 centimeter. If it is a concave lens, then that is a minus 25 centimeter. That is a minus 25 centimeter. Okay, now what they are asking? Combination, power of lens they are asking. 1 by f equals to 1 by f1 plus 1 by f2. Okay, now 1 by f equals to 1 by f1 40 minus, right? Again this is minus 1 by 25. Yes, I hope you clear. Okay, now this one 1 by f equals to, just take the LCM, that is 200. The LCM students 200. Okay, directly I will write this one. 1 by f equals, just f equals to minus 200 divided by, so here also you can take, that is LCM 200. Yes, this one 5 and this one 8. Yes, so no 1 by f. Take reverse, 200 divided by minus. Yes, but what they are asking, power of lens they are asking. Power. Okay, what is power of lens? That is 100 centimeter divided by f. It is a reciprocal of focal length. Okay, now this one 100 divided by minus 200 divided by 3. 0 cancel. Okay, goes up. That is minus 3 by 2. Minus 3 by 2, just divide this one. How much we can use ones? Minus 1.5. Diameter. Minus 1.5. Remember, if it's convex lens, focal length is opposed to concave lens. Okay, I'll move to the next one. A glass convex lens. What is refractive index 1.5 has focal length of 8 centimeter. When placed in air, what would be the focal length? Of lens when it is immersed in water? Yes or no? First, convex lens is placed in where they are placed students. Convex lens is placed in first air medium they are placed. Yes or no? Another one immersed in water. Yes. What is the focal length of second one they are asking? Yes. Okay. Here we know that focal length and refractive index are directly proportional to each other. Yes. But here I'll write that one. Refractive index, focal length of convex lens in air medium to the focal length in water. Focal length in water. Yes, equals to refractive index. That is refractive index of glass with respect to air. Right? With respect to air minus 1. Divided by this is refractive index of glass with respect to water. Yes. Okay. Now FA divided by FW equals to FA divided by FW equals to this one just what is the value 1.5 minus 1 divided by 1.5 divided by minus 1. Again this one. Here two are difference. One is refractive index with respect to glass and water. That can be written as 1.5 divided by 1.33 minus 1. Yes? Okay. Simplify this one. Simplify this. Simplify. Yourself to simplify. Here. This is the refractive index of water. Refractive index of this one. Focal length of water divided by focal length of air. Okay. Now, into this one. FW equals to how much we can get? 0.5 divided by 0.5 divided by this one is simplified 0.127 into how much? What is the focal length? Focal length is 8 cm. Focal length is 8 cm. FW in water equals FW in water equals to what is the answer we can get students? By multiply 8 cm. This one? Yes. No, not 8 cm. Simplify. 0.5 is 1 by 2. 4 again 6. Okay. Option D correct. I hope you cleared. I hope you cleared this one. I'll move to the next one. Two thin lenses of focal length 60 centimeter and other of focal length minus 20 centimeter are put in contact. The combined focal length is again simple problem. Here 1 by f equals to 1 by f1 plus 1 by yes 1 by f equals to just 60 minus 1 divided by 1. Yes, present sequence 1 divided by f equals to this is 60 1 minus 3. Now f equals to minus 37. Equals to minus 37. Right. I hope you written this one. I'll go to the next one. the radius of curvature of convex surface of a thin plano-convex lens is 15 centimeter, and refractive index of its material is 1.6. Then power of lens will be. Okay, first once I will calculate a focal length. Okay, what is the formula? The focal length equals to R divided by focal length is inversely proportional to, that is R. Here one directly proportional to R, but I am taking as this formula. 1 by F equals to N minus 1 by R minus 1 by R1 minus 1 by R2. Yes, here first these two are directly against this one, N minus 1. Okay, now F equals to, what is that? Radius of curvature of convex surface in plane of convex lens is how much? 15 centimeter. 15 divided by, then the refractive index of material is 1.6. 1.6 minus 1. Yes, okay, now here F equals to 15 divided by 0.6. 15 divided by 0.6. But what they are asking? They are asking power of lens. P equals to, that is 1 divided by F. But everything is centimeter, right? Okay, now this is 100 divided by 50 into 6 into 10 raised to minus 1. Yes, friends, simplify. Answer you can get. Simplify this one. Okay, move to the next one. Convex lens of focal length 0.5 meter and convex lens of focal length 1 meter are combined. The power of resulting lens will be same I given ones. Convex lens are given as well as concave lens. Okay, convex is positive, concave is negative. That is, just to simplify yourself, 1 by F equals to 1 divided by F1 plus 1 divided by F. Okay, this is 1 by F is how much? 0.5. Again, this is 1 minus 4. Okay, this is minus 1. Just this is plus minus 1. Okay, simplify. What is the answer you can get? Just check. Okay, so I'll stop here. I solved based on convex lens as well as lens maker's formula and concave lens also. Okay, now and surfaces. Okay, all these problems based on lenses. Okay, next class I will continue prism as well as materials, that is optical instrument surface. Continue. Okay, thank you.